Okay. Hello, guys. Good morning.
Good morning, sir.
Yes. So I think let me look at the names if I know anybody or second. Aditi, Rahul, Sanjana, Srihari, Siddharth, Srivatsa. Okay, fine. So we'll take 5 minutes. Okay. Please introduce yourself, right? Please, like I may know you, right, but your classmates may not know you, right? So yeah, even if I don't know, I'll also get to know. So yeah, please take your chances. Anybody can start. Just introduce yourself, right? Okay, which are all questions you have to answer, I'll tell you, right? So obviously your name, right? And which school are you from, right? And three things in the sense, in chemistry we have three parts, right? Hope you all know, right? It is physical, organic, and inorganic, right? So I want to tell which part is your favorite, right? So three things. One is your name, school, and your favorite part of chemistry. Yes, go on. Do you want me to pick names? Seriously. Are we still in 9th or 10th class? Go on.
Sir, may I go on?
Yeah, sure.
Sir, my name is Srivatsan. I'm from
Yes.
Shankara Adayar, and my
Okay.
favorite part of chemistry is, I guess, organic.
Nice. Thank you. Okay, next one.
Hello, sir. My name is Aditi Kannan. I'm from
Yes, sir.
Arsha Vidya Mandir, Gindi. And my favorite part of chemistry, I'm kind of stuck between physical and organic chemistry.
Okay, nice. Okay, next.
Good morning, sir. My name is Sanjana. I'm from DAV Public School, and my favorite part of chemistry is organic.
Organic. Wow, nice. Okay, next.
Sir, I'm Rahul from DA Public School. My favorite part in chemistry is organic and physical.
Good. DAV, which branch ka na?
Biology.
Biology. Cool. Okay. Next.
Good morning, sir. I'm
Good morning.
Sriharini. I'm from
Okay.
DAV Public School, Velacheri, and my favorite part of chemistry is inorganic.
Inorganic. That is very rare. Okay, thank you. Right. So I think all of you have introduced yourself, I guess. Anybody's left out? Harish. Yes, Harish.
So my name is Siddharth, sir.
Okay.
And I'm from Sam Academy.
Okay.
And my favorite part in chemistry is physical.
Physical. Cool. Right. Next. I think one or two are left.
So my name is K. Harish, sir, and I'm from Sunshine
Harish.
Senior Secondary School.
Which school kana?
Sunshine, sir.
Sunshine. Okay. Fine. I know. Yeah.
Yeah, my favorite part is inorganic, sir.
Inorganic.
Yeah.
Cool. Right. So, yeah, let me tell about myself. Right. Hope you want to know. Right. Like I gave a little bit of introduction in your webinar. Right. So yes, for those of you who don't know my name is Akash. Right. So yeah, and I'll be handling chemistry to you. Okay. So what else? So I have been doing this. Like I have been teaching chemistry for the past 6 years. Right. So 6 years. Like my age and the experience doesn't go hand in hand because, like you can see, like I'm not that old, right? But still 6 years. How? Because I started teaching chemistry when I was in college, like say when I was in second year of college. I hope you all know Time Institute. Anybody has known Time Institute? Nobody knows. Time is literally
Time Institute. P.I.M.
Yes, P.I.M.D. Yes.
Yes, sir.
Okay. So I studied college in Shastra University. Or some of you might know, some of you don't know. Right. So when I was in second year, so I thought like, okay, let me do something for my pocket money. So I started teaching in Tanjore. Right. So that's how it all started. Right. So there it was for 2-3 years. Then like hope you know Byju's. Obviously you should know. Right. Almost everyone is following cricket. Right. So I was working in Byju's for 3 years. Right. So that makes up for 6 years. Right. Now I am doing my integrated PhD from Indian Institute of Science, Education and Research. It's called ISER. right? IISER, Indian Institute of Science, Education and Research. I'm doing my MSc plus PhD. It's an integrated course, right? So that's I'm doing chemistry, obviously, right? And you can look at this thing. Say, I did my BTech in electronics and instrumentation, right? But look at what I'm doing now. Like, not with respect to what I'm studying, but what I was doing for my profession itself is not connected to what I studied, right? So yeah, most of the engineers' cases like this, isn't it? Right. So yeah. So how is it? Because like I started teaching just for some little financial stability, but still it became my passion. I love the subject too. Like it cannot be explained. I love that. I like the subject this much, right? And I'll make sure, like I told you, right? I'll make sure that you also like this subject very much, right? Okay. So yes, I think that's about me. And yeah, my favorite part, right? Organic, inorganic, organic. It would be organic, then physical, then inorganic, right? So inorganic, again, this is a very general statement, right? There are few areas in inorganic I like very much, right? There are few areas in physical I love, right? But yeah, overall, organic, physical, and inorganic, right? So I think that was a pretty good introduction. I knew about you, know about me, right? So guys, right? So we know that we are actually going to compete with almost like 15 lakh students for this JEE. Like, you know how many people write every day, every year it's increasing, right? So let me put it in a nutshell, right? Say my part, right? My part of teaching or what I can do for you is almost like 30 to 40%, right? Rest 50 to 60%, right, is actually in your hands, right? So please understand, people, this is like if you're academically strong, that is, if you're good in studies, that doesn't mean that you will get a college or you will get a seat in IIT. No, it's not like that, right? You have to be good, yes. Like sometimes people who are average, I have seen so many people, so many students in my these years. I've seen people will be very average when they come for 11th, like they were on 12th, but still I'm telling 2 years, right? When they start after 10th, they'll be very average, but 11th and 12th, they'll pick up like something. And then they will fear, and then they will eventually join NIT or IIT, right? So what I'm telling you is, it is not about whether you are good in studies or not. It's not about how much marks you're scoring in your school. No, it is not about that, right? So even though, CBSE and JEE will have almost similar syllabus, like there and there, almost like 80-90% is same, right? The rest 10% is what is little portion, something like the syllabus, right? Little higher. Higher in the sense, little more you have to study, only 10% more. But that is not the difficult part. The difficult part is about you practicing every day, right? Let me tell you, if at all now we already started little late, we started only in September, in March or April, you will have your exam. Make sure you are at least spending 2 hours per subject per day. I'm not only talking about chemistry, right? It should be 2 hours per subject per day, right? So again, in the 2 hours, what you should do, that also I'll tell you, right? So please do not go on sitting with your book and studying. Please do not do that, right? So if you're really interested, right, if you're really interested to crack these exams, you're really aspiring to go to IITs, right, that 2 hours should be exclusive for problem solving, right? So hope we'll be giving you worksheets, we'll be giving you assignments, you'll be going for tests, all those things. So all these things has to be done. It is not for me, it is not for anybody else, it is for you. You are going to do it, right? So like, see, some people say, a person X can do, say, 15 problems in 2 hours, right? Or say 10 problems in 2 hours. Another person Y can do only 2-3 problems in 2 hours. Doesn't matter. Really doesn't matter, right? All it matters is whether you're starting, whether you're doing it, right? So the person, say for example, the person Y, right, who was able to do only 2-3 problems per day, but he kept on doing it. In 1 month, he'll be able to cross that guy who was able to do 10 problems in 2 hours. If given that X guy is not doing much, right? So it is all about keeping in touch, constant perseverance. Like sometimes you might even feel, what the hell is this? Like I'm doing something, I'm not getting the answer, I'm not getting the marks. Please do not be frustrated, right? It is not only you, right? There are so many kids like you, so many students like you who are preparing for this, who are getting frustrated, who are getting irritated, right? But still, whomever is going to be strong, right, is going to come out a winner at the last, right? So please have these things in your mind, right? So whenever they say this has to be submitted, again, we are keeping deadlines just because you will submit it, right? Actually, we don't want to keep deadlines. It must be from your efforts. You should tell me, sir, I completed. So what is this? How this question came? How that question came? That should be the interest, right? So yeah, this is the whole picture. So please make sure that at least you spend 2 hours, and in that 2 hours, please solve problems. Do not study. Do not study. Say, for example, if you're doing a problem and you don't know the concept, right, or you don't even know the formula how to do it, then you go back, check the theory, and then again come back. That should be only 5 minutes. Just looking at the theory and then trying to solve the problem. And again, in that 2 hours, let me tell you, even if you are not even getting one answer, completely all right. Trust me, right? Even if you're not even getting one answer correct, trust me, it's completely all right. You will get on track, right? So the hope, the determination, the courage, right? All these things are required. Okay, so I think I made some sense, right? So yeah, so how are we going to start? So that's about the preparation part, right? So again, I'll be telling you, I'll be in this course in the next 6-7 months. I'll be keeping on telling you, hey, please solve problems, please go for some test series, like say, write as many as tests, right? Ask as many doubts, solve different kinds of problems. All these things I'll be telling you. Okay, so that is about the preparation part. Now coming back to our subject, right? So there are going to be almost like 23 to 25 chapters in chemistry, combining 11th and 12th, right? So we are not going to segregate the chapters like 11th and 12th. No, I'm not going to do that, because now is not the right time to do that, because we already know, like, we are almost in September end, right? So what will I do is I will take organic first, right? I will take organic first. With 11th and 12th, I'll complete it. Then I'll go for physical, then complete it, 11th and 12th. Then inorganic, completing it, right? So this is how we'll be going. And sometimes I might ask you to come for extra classes, right? Other than the allotted 3 hours, right? So I don't know about mathematics and physics, but I will definitely call you for extra classes, right? So the thing is, chemistry is very vast. Okay, so people think like it's a very easy scoring subject. Yes, it is easy scoring subject. I am not denying, but the thing is, you have to chemistry is one subject which you have to keep on, keep constant touch with, right? Say, for example, today you are able to do a problem, you are able to do 10 problems in a particular chapter, right? Say after 1 month you try that, you might not be able to do it, right? So why that happens in chemistry is because you have to keep in constant touch. There are small things. So it's not like physics. I know the logic, I know the formula, I apply it, I get the answer. No, same in mathematics. I know the concept, I know how to do the problem, I'll do it. It's not as simple as that here. You have to remember a lot, right? There are so many exceptions which will come, right? So more like for every reaction or every mechanism or every other concept, you will see that this particular thing will not follow this law. There are reasons for that. Again, you have to remember the reasons also, right? So chemistry is going to be this way, okay? And do not worry about the concept, concept understanding. That is in my hands. That will be taken care, right? All you have to do is listen to the class. Go after the class. Please go and start solving problems. That's the only thing which is required from you, right? So any other question of how we are going to do, or any other doubts regarding any other things, people?
Okay.
Yeah. So,
will the practice problems be daily or weekly, sir?
That is not decided yet. I'm telling Akhila that it should be on a daily basis, right?
Okay.
But what we will plan is, see, since we are meeting only once a week, twice a week, I say 3 hours, right? So at the end of Sunday, say Saturday we have a class, Sunday we have a class. At the end of the class, at the end of Sunday, you will be receiving a worksheet or an assignment, whatever it is, right? So it might contain some 30-40 problems, right? 30. This is for first subject, right? So it may contain some 30-40 problems. So at the end of next Saturday, right, before the classes start, right, before that Friday night, it should have been submitted. Like that is how it should be. Right?
Okay.
And please do not keep it the Friday is my submission, so I'll start on Friday. Do not do that. The assessment should be on daily basis. Yes, even though we are giving you like say a bulk of problem, a bulk of problem to you in one way, like in one go. It's not like that. You should also do that. No, right? If at all we are meeting daily, yes, I can give you daily 5 problems, 6 problems for you to do that. But now here it's not possible, right? So on a daily basis, please solve 5 problems, 6 problems. Start with that.
Yes.
Does that answer your question?
Yes, sir. Yes, sir.
Oh, okay. Right. Any other doubt, people? Okay. So I assume that everybody, yes? I think someone said something.
Sir, how will the tests be conducted?
It will be in the app, Kana. Like you have Excellent has its own app, right? So there you'll be writing the test. Even the assignments and worksheets which you'll be giving, you will be solving it, scanning it, and putting it in the app, and we will go through it. That's how it is going to be. So everything will be through the app, other than the classes, right? Classes will have to happen through Zoom, but other than that, all the other things you will be going through the app. Even tests, assignments, or whatnot, everything else will be through the app. It's like online. You're going to write it online only, JEE. So that will be an online test. You just have to just click the correct answer. That's it. Right?
Okay, sir. Okay.
Okay. Right. So yeah, people, that is a good enough introduction, isn't it? And one more thing, right? See, there's a disclaimer like this. I tell for every batch I start, right? Okay, I like you can see from here itself what I'm trying to say. My handwriting is pretty bad. Pretty bad, you can understand definitely, right? But sometimes, if you're not able to understand what I'm writing, please feel free to tell me, sir, what is this, what is that? Please unmute yourself and ask. Okay, and that is one thing. Second thing, when I'm asking, right? Hey, what do you think is the answer? Right? I do not care whether you're giving me a correct answer or not. I really don't care, right? What I really care is that you're unmuting and saying something. If it's good, good. If it's not correct, then also it's fine. Completely all right. It's all about participating, right? So sometimes what happens is you might have a doubt, right, and you will not ask, right, but someone else will ask that doubt. So some way I'll be able to call, like some way you'll be able to manage, right? So since you have only 6-7 people in this batch, it might increase definitely, right? But so we have anyways going to have a very less strength. Please use this, okay? And all these things will be recorded. All these classes are happening all these weekends will be recorded to you. Okay, so whenever you feel something is little lacking the concept understanding there, you can always go back and look at the concept, right? Okay, and I want to tell you one more thing, and then we'll directly go for the class. So guys, I want you to buy some books if possible. It's not possible. It's highly advisable, right, that you buy these books. Okay, so obviously for physical chemistry, you have to buy one book, organic one book, inorganic another book, right? Okay, so let me tell you the books, okay, so which you have to buy. So for organic, right, so go for, what is this guy's name? Shahi, no. What is this guy's name? I forgot. Okay, so let me tell you this later, right? There are 3 books which I want you to buy. Physical, I can tell you. Physical, go for Ranjit Shahi. Physical chemistry by Ranjit Shahi for JEE. This is by the JEE edition. Okay, and for inorganic, by JD Lee. Again, JEE edition. There are so many editions. They'll have global editions. They will have neat editions. Go for JEE edition for both of these. And for organic, I forgot the name. Okay, let me tell you that later, right? So we're going to start with organic, but don't worry. Tomorrow's class, maybe I'll tell you. Or if I remember that name before the class ends, I will tell you. Okay, fine. So these 3 books, along with organic, which I'm going to tell, please buy it, right? So this books will have both the concepts as well as good number of problems, very, very good number of problems, right? So try to solve from that also, and from the worksheets and assignments which are going to give. Okay, right? And what else? And yes, one more thing is that for every chapter, if you can buy this book also, it will be very helpful. You can have this chapter wise JEE past year questions, right? So it is given by this Arihan Publications, right? So it will have, say, for example, say if I take what is that? Say solutions chapter, right? So solutions chapter, it will tell, okay, 2019 this question came, 2018 this question came, and they'll give you the answers also. Okay, all the questions from 1980s till the last exam, that is this exam was got over, right, by the latest edition, right? So that will have all the previous year questions chapter wise, right? And then we'll have solutions also, right? So this is the flow, right? After I complete the chapter, after I complete one chapter fully, okay, the first, obviously in between the chapters you will be doing the assignments and stuff, right? Right after I finish one chapter, the first thing you will do is go solve the questions from this, okay, past year questions, which were already asked in JEE. Okay, that's the first thing you will do. Then if you have time, or it's really advisable that then you can solve questions from these books, extra questions, right? So if you're going to do all that, it is set, right? You are set for the path, right? Cool. Yes. Okay. So I think hope everybody's taking it down, or else I can again tell you if you wanted some other time. Okay. Cool, people. We'll directly go to our class, right? Fine. So I told you that we are going to start with organic, right? Okay. So 11th, we have two chapters in organic. One is general organic chemistry. The other one is hydrocarbons, right? So if you can, say these chapters are very, very, very important for us to understand the concepts in 12th. We have, I know, so many chapters: haloalkanes, haloarenes, alcohols, phenols. All these chapters are there. So if at all you really want to understand the real grasp of it, right? You need to know these two chapters. Right? Most of the reactions would have, like, at least say 30% of reactions you can see it in hydrocarbons itself, right? So that is one thing. And I don't know how you studied organic, so definitely I know how CBSE teaches organic, right? They will just tell you give the reactants, products, and the catalyst, right? That is never sufficient, right? For all the reactions, whatever the reaction is, right? You are going to know the mechanism of the reaction, right? You are going to know the mechanism of the reaction. Mechanism, you know what is the mechanism, right? The inside thing, what is happening? How is it that the reactants are getting converted to products, right? So all these inside things are very, 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 very important, right? So that is how we will be teaching also. If you're not going to do that, it is really boring to study organic, right? So most of you told that already organic is interesting. So I'll give you a heads up. I'm going to blow your mind. That is how it's going to be, right? Fine. So cool, people. So we are going to start with general organic chemistry, right? Okay, fine. So let me start with this. Okay. Now please understand, people, for any organic reaction to happen, right? For any organic reaction to happen, I will be able to give you a general flow chart. Okay, this is how an organic reaction happens, right? So what is the flow chart? This is how it goes. So I have something called as substrates, right? I have something called as substrates. Substrates are basically reactants, right? Say it can be alkanes, aldehydes, ketones, carboxylic acids. It can be anything. Amines. It can be anything. Okay. Now these substrates are going to get attacked by something called as reagents. Okay. These substrates are going to get attacked by something called as reagents. Okay. Now they will react together. Okay. So the reaction will move forward and forward and forward. So you will see in the middle, right? In the middle of the reaction, they will react together to form these intermediates. Okay, so these intermediates are unstable species. Right, these intermediates are unstable species. Right, so these unstable species will gain something or lose something. Right, this will gain something. Say they lose a proton, they will accept a proton. Say they will leave the bromine group. Something, right? They will accept something or gain something to form the final product. Right. So this is the general flow chart of any organic reaction. Right. So I have substrates. These substrates are going to get attacked by something called as reagents. Right. So they will react together. In the middle of the reaction, I form something called as intermediates, which are unstable. Right. So these intermediates will lose something or gain something to form the final product. Right. So this is what we call a mechanism of the reaction. Right. So you have to know what is the intermediate. You have to know the reagent where it is attacking the substrate. Right. So all these things makes up the mechanism of the reaction. Okay. So for us to study how an organic reaction happens, right, we really need to know what are these reagents. Substrates we know. What are all the substrates? I know alcohol, ethers, phenols, all the things are there. That we already know. So we have to talk about the reagents. We have to talk about the intermediates, right? And obviously product will again be an alcohol or ethanol or a phenol or whatever it is, right? So the concept of these reagents and the intermediates are very, 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 very important. Okay. And before that, I have to know certain things about your substrates also, right? Now, what happens is we know that there are going to be something called as isomers, right? So different isomers will react differently with the same reagent. Say, for example, I have cis butene, right? I'm telling, hope you know what is cis and trans. Don't worry, do not worry if you don't know. We'll again see all that, right? So cis 2-butene will definitely have a different reactivity when compared to trans 2-butene, right? So the isomerism part, or say you would have studied about your optical polarities, not optical polarities, optical rotations, right? Optical isomerism, right? So all these things are very, 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 very important. Okay, and like not only that, there are other forms of isomerism also, which might definitely, for example, if you go for your aldol condensation. Okay, and I want to ask you, for in how many of your schools all the chapters are already completed, or almost going to get over, something like that?
They're almost gonna get over.
Almost gonna get over.
Okay, okay.
We
So
still
have they
have a few
completed the
chapters
end?
left, sir.
Okay, have they completed the entire organic part at least?
Sir, organic only konja, they have little left, sir.
Okay, organic only little left. Fine, no problem. So that means you know the basics of it. That's what I wanted to know. That's it. Okay. So what I was telling? Yeah. So we're talking about isomerism, substrates, right? So we'll study about substrates for a little while, right? We'll study all the possible types of isomerism available, right? Then we'll go for reagents. There are only going to be two types of reagents. Okay, so they're basically going to be something called as nucleophiles and electrophiles. Right, so these two are the general types of reagents which you can have. So nucleophiles means negative charged species, not necessarily, but still generally. Right. Again, we'll talk about it in a separate class itself. We'll talk about reagents later. Right. So again, intermediates. I can have 4 to 5 different types of intermediates. Say I have something called as carbocations, carbanions. Say I have free radicals. I have something called as carbenes. So many are there, right? So 4 to 5 are very, very important, right? So again, we'll have a separate class for that. We'll study about them, right? So today's class, let me concentrate on substrates. Okay, fine. So you must already know this, right? So when actually this chapter starts with naming, IUPAC naming, right? So IUPAC naming, why am I not concentrating is because no question is going to come from an IUPAC naming. Even in advanced, even if you go for advanced, right? No one is going to ask you, give the IUPAC name of this compound. But how questions will be asked is, say I have 2-methylpropan 2-ol reacting with something else. So at that case, you need to know how to write the structure for the given name. That is what will be checked. Right? So that too, they'll not be giving you very complex things. Very simple things that we will be giving you, and you have to write the structure and then go for the reaction. That's the maximum thing they'll be able to ask with your naming. Okay, so you don't have to worry about naming, right? I hope everybody is comfortable with naming. I hope.
Yes,
Are you
sir.
fascinated? Okay. So if not, if you find any difficulty, please ask me. I'll be able to help you. But again, I don't think you will get a chance to even ask me something about IUPAC naming, because no questions will come. Even if it comes, it is going to be a simple question. Again, it will be application saying that this particular name of the reactant is reacting. What is the product? Something like that. Okay. So after that only we go for isomerism. Okay. So we already know what isomerism is, isn't it? Can someone tell me what isomerism is?
When they have
Same.
the same molecular formula but different structural formula.
Okay, so that's what we have been studying from the lower classes, isn't it? Same molecular formula but different structure, right? So yes, it is partially correct, right? But there are some missing statements there, people, right? So isomerism, yes, they are going to have same molecular formula, right? But they can have different structures. That is one point. Or they can have different orientations of atoms in the 3D space. Again, I repeat, right? So isomerism is a phenomenon where molecules have same molecular formula but different structures. That is definitely one thing. Or the orientations of atoms. That is, for example, how do I tell you is cis and trans is also this thing, right? So what happens in cis and trans? Do you see any molecular form? I mean, structural formula difference? No. But where one methyl group is one of the isomer, that methyl group will not be exactly pointing towards that direction. It will be pointing towards some other direction, but still same structural formula, right? So the thing is, when someone asks you what isomerism is, you should tell that it is a phenomenon where molecules have same molecular formula, but different structures or different orientations of atoms in 3D space. Okay, right? So fine. So based on these two, right, now tell me, what are the two different types of isomerism? Broadly, I'll be able to classify isomerism into two types. What are they?
Stereoisomerism.
Okay, one is stereoisomerism, other one?
Geometrical isomerism.
Geometrical isomerism comes under stereoisomerism.
Structural isomerism.
Correct, right? So I have two basic types of isomerism, that is structural isomerism. The other one is stereoisomerism, right? So as the name, as I gave you the definition, there are going to be two things: same molecular formula, but different structure. Structural isomerism, different orientations of atoms in 3D space. Stereoisomerism. Stereo basically talks about the 3D structure. Okay, right? Fine. So now going to structural isomerism. Again, I have so many types under this. Okay, so many types under this. So one can be, okay, you tell me, what are all the different structural isomerism you know?
Geometrical isomerism.
Geometrical isomerism comes under stereoisomerism.
Chain isomerism.
Yes, chain isomerism is correct. Then
Functional
isomerism is also correct. Yes, then position. I have something called as position isomerism. Position, chain, functional. These are the three basic things. Okay. Other than that, I have three more which you might not know, but you must have definitely heard about it, right? So, okay, I don't have space. Okay, fine, I have some space. So I have something called as metamerism. Have you heard of this, people? Metamerism?
Heard of it?
Yes, sir.
Heard of it. Okay, I'll teach you. And if you don't know, it's completely all right. Right. So metamerism, and also I have something called as a ring chain isomerism. I think from the name itself you can understand. Same molecular formula, but one will be a ring structure, the other will be a straight chain molecule. Right. So that is about one second. That is about ring chain, and one more last one is what is called as your tautomerism. Right, this also you should have heard, isn't it? tautomeric, right? So okay, so we'll see one by one. I would say not most like some of them are we already know, right? Okay. So for example, first let me complete the different types. Okay, now when I go for stereoisomerism, right? When I go for stereoisomerism, I have two types only. There are so many types in structural, but there are only two types in what is that, stereo, right? So one is, as you said, geometrical isomerism. Right? One is geometrical isomerism. The other one is my optical isomerism. Right? The other one is what is called as optical isomerism. Now, I think the first chapter in your haloalkenes, haloarenes, you would have studied about chiral molecules, chirality, D, L, texturorotatory, levorotatory, right? So all these things. Okay. So geometrical isomerism and optical isomerism. Obviously, you understand, right? How geometrical isomerism we already know, cis and trans, right? So we know the orientations of atoms in 3D space is different, right? So even for optical isomerism, I know for different enantiomers, I'll have different orientations of atoms in space. But if you don't know, again, it's completely alright because you're going to see it, all these things again. Okay, fine. So geometrical, and please understand the geometrical isomerism is also called as diastereomerism, or they are also geometrical isomers are also called as diastereomers. Right? Geometrical isomers are also called as diastereomers. Anyways, we'll look at all these things. Again, I know that in optical isomerism also I get diastereomers, isn't it? So don't worry, I'll tell you all that. Right? For now, we are just starting. Okay. So fine, let me start with structural isomerism. Right? There are certain things that are very easy, certain things I have to spend time. Right? So we'll see all that. Any doubts till now? Right? I hope everything is okay. We didn't see much yet, right? Okay. Okay. So let me start with position isomerism. It's very simple. I don't want to spend so much time on this. Okay. So position isomerism, as the name tells you, the position of the functional group or a branch is going to change, right? So again, I repeat, I'm going to have change in position of a branch, say CH3 is a branch, right? That is one branch. And say, even I have different functional groups to be in different positions, but same molecular formula. For example, let me give you a very simple example. Say I have CH2, CH, CH2, CH3. This is my but1-ene. Right? This is my first carbon atom. Right? Now, same molecular formula, but I can write a different structure. I can write as CH3, CH double bond CH, CH3. Now, what do you see? This is my but1-ene because there is the double bond is in the first position. Now, here you can see this is the second position. So, this is going to be called as but2-ene. So, what do you see? Everything is same. The chain length is same. Everything is but and but. Four carbon atoms in the main chain. Everything is same. But what is varying is the position of the functional group. The number, the carbon number of the functional group is changing. Right? So one more example I can give you. Say, for example, I have one OH and another OH here. Right? This is my cyclohexane with two OH groups. Say another thing, the isomer, the position isomer of this can be, say, one OH here, the other OH here. So now, how will you name this? We know that it is going to be called as cyclohexane 1,2 diol. This is the first carbon atom, second carbon atom. So it's going to be called as cyclohexane 1,2 diol. Right? Now, what is going to be different here? Here I have 1, 2, but 3. So now here it's going to be same thing, cyclohexane 1,3 diol. Right? So this is what is called as your position isomers. So the number only is going to change. Nothing else is changing. Only the number of the
functional groups number, sir.
Sorry.
The position of the functional group only, no, sir.
Correct. So in this case, you see that the functional group is alkene. In this case, you see that the functional group is OH. But I don't even I don't even need any functional group. I can just have a branch of methyl group that can also be different. Say, for example, I can give you this example. Say I can have CH3 CH, CH3, CH2, CH2, CH3, right? So this is going to be called as 2-methyl, 1, 2, 3, 4, 5 pentane, right? And I can write this position isomer of this, like this, CH3, CH2, CH, CH3, CH2, CH3. Now what you see is different. Instead of 2-methyl, I have 3-methyl. That's it. So again, it need not be always found. Yeah.
If it's a substituent also, sir. If it's a halogen substituent also.
Anything. So I can here instead of this CH3, I can have a chlorine here. That is one. So I can put the chlorine here also.
Okay.
Right? Or I can put the chlorine here also. That becomes 1 chloro. This becomes 2 chloro. This becomes 3 chloro. But again, same molecular formula, but different positions of the functional groups or say the branches. Anything.
Okay, sir. Thank you.
Okay. Right? So this is about your position isomerism. Only the number, everything will be different. Functional group is same. The number of carbon atoms in the main chain is same. The only thing which will be different is the number of the branches or say the functional groups for that matter. Right, cool. So that's about position isomerism. Okay, let's move on. Right, so we'll move on to see what is this chain isomerism. Right, so in position isomerism, what you saw is only the number is varying, only the position of the functional groups or the branches are varying, right? But in chain isomerism, the chain length, say for example, in one of the isomer, I can have but or say pent, right? The same molecular formula, but the IUPAC name will contain only prop, or say if it's pent, I can have but or prop, something like that, right? The chain length is changing, right? Say I'll give you an example. Okay, say I have CH3, CH2 twice, CH3 normal butane, right? So now I can write this as CH3, CH, CH3, CH3. Now this is my N-butane, right? What is the name of this? 2-methyl propane. Same molecular formula, but different structure. Now look at this. I have prop here, but here I have but. So whenever you see the root word changing, what is root word? This based on the number of carbon atoms in the main chain, they gave the root word as meth, eth, prop, but, pent, all that. Right. So if you see that the root word is changing, right? Now that gives an information that these two are going to be chain isomers. Okay, right? Just that. See, you can have a combination of chain as well as position together, right? All these things you have to take care. Okay, all these things you really have to take care. Okay, fine. So that's about position. Sorry, chain isomerism. Okay. Next, I'll go for. Okay, hope everybody understood this. Very simple, right? Only the root word is gonna change, right? Okay. We'll do problems on this. Don't worry. We'll do a lot of problems on this. Okay. So next, I go for this ring chain isomerism because it is little related. Okay. So as I already told you, right? For this same molecular formula, but one of the molecules will be a straight chain compound, aliphatic compound, right? Aliphatic means straight chain. I hope you know this. I have something called as aliphatic. I have something called as alicyclic, right? Aliphatic means straight chain compounds. Alicyclic means cyclic structures, ring structures, right? So what I'm telling is same molecular formula for rings and isomers, but one of them is going to be a straight chain compound. The other one is going to be a ring structure. Cool, right? So, okay, let me go for it. Say, for example, now please understand, people, right? For ring chain isomerism, the straight chain molecule should contain at least one double bond, right? Why? You know, right? Say if I write it like C4H8, right? If you take the molecular formula C4H8, okay. So now what are those structures I can write? So obviously I can write CH2. This is an alkene, right? CnH2n. CnH2n plus 2 is for alkanes. CnH2n is for alkenes. CnH2n minus 2, will be for your alkynes. Correct. So I can write the structure CH2CH, CH2CH3, or I can give the position isomer of this. I can put the double bond here. That becomes the position isomer. Now I can change the length. I can make it 3 carbon atoms in the ring. 3 carbon atoms in the chain. Make it chain isomerism. All these are already possible. Other than all those, right? I can even write cyclobutane. Right? Cyclobutane, I'll be able to write. Again, check it is CH2. All these are CH2, CH2, CH2. Correct? Right? So again, what do you see? C4H8. Right? So these two are what are called as your ring chain isomers. I can write more if you want. Right? So I can still write the ring chain isomer of this to be, say, I put a cyclopropane. And what should I do? Tell me. I'm writing the isomer of this compound, or say this compound in this form. What is missing?
CH2.
Sorry?
CH2.
CH3. Ah, yes, correct. So I have to put a methyl group somewhere. Correct. So again, these two becomes isomers. Right? Okay. So that is about your ring chain isomerism. Okay. Now we will do some problems, I guess, on this. Give me 1 minute. Yeah. Oh no, not this. So guys, I have a library with me. Almost like a mini library. So yeah, I got it. 1 second. Okay. Let me see if you can do this problem. Okay. Take on this question. Actually, people, like this is the first class. So generally, I don't do this for CBSE. But for your JEE class, what I have planned is the questions. I'll not be dictating you the questions because it will take a lot of time. So what I'll do is I'll click a picture, right, and I'll share my screen from next time. Okay, so you can just see the questions on your screen itself. Okay, so today alone you adjust. I'll just please take down your question. Take down question. So from next class, I'll be sharing the screen. You can just look at the screen and start answering in your thing. And whenever you want to go back, you can always go back and check what was the question because it's recorded, right? Okay, so please take down the question. How many cycloalkene isomers? How many cycloalkene isomers exist for? How many cycloalkene isomers exist for C5H8? The molecular formula is C5H8, which contains at least one methyl group as a branch. Which contains at least one methyl group as a branch. Right? So I repeat the question. How many cycloalkene isomers, cycloalkene, not alkane, please, the cycloalkene isomers exist for C5H8, which contains at least one methyl group on a branch? Like which branch? At least one methyl group in all the formulas you write should be a branch. There should be a branch of methyl group. Go for it. I'll give you 2 minutes or 3 minutes. Just tell me the answer for this question. How many? So it should be a cycloalkene. Remember, it should be only ring structures. And in the ring structure, I should have a double bond. The other condition is I should have a methyl group wherever possible. I mean, in all the structures that you write, right? There should be one methyl group as a branch like this. Right? So yeah, go for it. Let me see. And I know I'm going to get different answers from all of you because this is a common thing which happens in isomerism. Right? Yes. Any answers?
Sir, I'm not sure, but is the answer 3?
3? No. Like they say, there are options like 2, 4, 5, 6. Those are the options. Okay, so 3 is not there. I don't know. Like maybe if you have given me any of the choices, I would have told maybe I will check. But the 3 is not even in the options. Any other answers, people?
Hi, sir.
Yeah.
5.
5. Okay, yes. 5 is there. Okay, 5 options are there. We'll check. Right. Fine. So I think the time is enough. I can give you the answer. Okay, first answer my question. Can I have cyclopentane structure? Can I have here? Guys, I'm asking. Can I have cyclopentene structure here for this question as one of the isomers?
No, sir.
Good. Why?
Sir, because there needs to be one methyl group, sir.
Absolutely. Right. So guys, you should not write this structure. No, this is an isomer for C5H8, but for this question, it's not the answer. Right. So this is not there because they have told that one methyl group should definitely have a branch, which means that means you have to start only with 4 membered rings because one has to be there in the at least one should have been there in the branch methyl group. Right. So this is not there. Right. So let me start with the cyclobutene ring. So I have cyclobutene ring. Right. Now I have to put a methyl group. Right. Now I can put the methyl group here itself or here itself. Again, same thing. Please, like the one more thing which I have to be very careful is redundancy. Redundancy means you feel like these two molecules are different, but they eventually turn out to be same. Now, how do you avoid that? You avoid that by giving the IUPAC name of the compound. Right? If you find that two of them are having same IUPAC name, that means only one of them is correct. The other one you should take it out. Right? That's the trick. Right? Again, I will not be able to go through all of it because I'm so much practice. But if at all you find the difficulty, if you're finding that so many redundant molecule structures you're giving, make sure that for after every structure you give, go for the IUPAC naming, and then you will get to know whether it's same or different. Right? Okay. So this is one structure. The other structure, again, same thing in your cyclobutene only. Now, instead of putting the methyl group here, I can put it here, right? Or I can put it there also. Again, it's going to be the same. So only two structures are possible with cyclobutene, 4-membered ring. Okay. So now I can go for the 3-membered ring. Again, I should have a double bond because it's cycloalkene, Right. Now I have to account for two methyl groups. Right. I have to account for two methyl groups. Now, where can I put the two methyl groups? Now, please understand, people. Here I have two bonds. Here I have only one bond. Here I have only one bond. Okay. So the first possibility can be you can put one methyl group here and the other methyl group here. That is one possibility. Or again, I'm putting a double bond. Say I put one methyl group here, the other methyl group here. Right? So you can see what to say. Okay, this is one thing. The next one, I have one. Now I can put both the methyl groups on the sp2 hybridized carbon atom. Wait, I have to know whether you know this or not. Guys, if a molecule is unsaturated, sorry, saturated, right? If a molecule is saturated, that means, hope you know what okay, first, tell me what do you mean by saturated compound? What do you mean by a saturated? Yeah, what is it?
Single bond.
Only single bonds are there, no double or triple bonds. Those kind of molecules are only called as saturated molecules. Right. So in saturated, say for example, alkane, for example, right? What is the hybridization of carbon?
sp3.
Good. Okay. So if I have a C double bond C, what is the hybridization of this carbon?
sp2.
Good. Okay. Now if I have a triple bond C, triple bond C, in this case?
sp.
Okay. Guys, how many of you don't know this? You don't have to feel shy. It's completely all right. Tell me who didn't know all this. If I have no double bond, no double or triple bond, it's sp3. When you have a double bond, the carbon atom is sp2. When I have C triple bond C, it is sp. How many of you didn't know this, people? Please tell me. I can, because I'm going to explain if you don't know. That's why I'm asking.
Sir, I know it, sir, but I forgot a bit of it.
Okay, no problem. Fine. We'll finish this question and then I'll go for hybridization. Cool, right? Okay. Fine. So what I was telling, yes. So now you put one CH3 on the sp3 hybridized carbon atom. Why again? I'll come back to this if you don't know. So sp3 because there is no double or triple bond, right? So one of the methyl group is an sp2 hybridized carbon atom. This is sp2 hybridized. This is sp3 hybridized. Okay. Now the next possibility is I can put one methyl group each on the two sp2 hybridized carbon atom. Right? Any other possibility? I have one more possibility. Let me see. Like I said, someone said 5. So I think these are all the structures you got, Pranav?
No,
Someone
sir.
said
You did
5?
wrong, sir. No, sir.
You did wrong. Okay,
Yes, sir.
fine. So other than these 5, I have one more also. Who can guess? Actually, oh yeah, I think that's it. Yeah, these are the 5 things. Correct. So actually, if they didn't give you, there should be a methyl group, right? So one thing is obviously I can have a cyclopentene structure. The other thing I can have is I can put a cyclopropane with a double bond. I can put a C2H5. What is C2H5?
Ethyl.
Ethyl group, right? Correct. It's ethyl group. So I can do that also, but for this question again, this is not correct because they said at least one methyl group should be there on the branch, right? So yeah, these are all the 5 different structures. This is how questions will come from your isomerism also. We'll do one more. Oh yeah, wait. We'll go back to that. What is that? Your hybridization, right? Okay. So yes, you can copy this down if you want. I'll give you 1 minute. Okay, fine. Okay, so we'll talk about this hybridization of different things because it's very important. Like questions, not directly will come from that, but again, if you don't know these simple questions, you might not be able to answer. Okay, so people, we'll again see this in chemical bonding. When I go for chemical bonding, again teach you all this how to find the hybridization. But still, I'll now give it to you in a very nutshell. Right, there is a formula to find out the hybridization. Okay, there is a trick by which you'll be able to find the hybridization. Okay, so that is equal to, there is something called as steric number, Sn. Okay, so based on the steric number, what value I'm going to get, I'll be able to predict, okay, this molecule, this atom is this hybridized. All these things I'll be able to tell. Okay, so Sn is equal to, steric number is equal to number of atoms attached to the central atom, right, plus the number of lone pairs in the central atom. So when I put Ca is central atom. Okay, Lp is lone pairs. Okay, so steric number is equal to number of atoms attached to the central atom plus number of lone pairs on the central atom. Right. So this steric number, for example, if you find steric number to be equal to 2, for example, I'll tell you how to calculate all this. So when you find that the steric number is 2, right? So that means whenever you see this 2, that means 2 atomic orbitals are combining together to form a hybrid orbital. Right? Again, I repeat. Whenever you see that a steric number is 2, right? So that means 2 atomic orbitals are combining to form 2 hybrid orbitals. So you always remember this. I know that atomic orbitals are going to combine together to form a molecular, to form hybrid orbitals. So the thing is, the number of atomic orbitals combining should be equal to the number of hybrid orbitals formed. Okay, so if at all you see the 2 atomic orbitals combining, there should be 2 hybrid orbitals. 3 means 3, 4 means 4. Okay, so here what I'm telling is, if you find that the steric number is 2, that means 2 atomic orbitals are combining to form 2 hybrid orbitals. So what do you think will be the hybridization? Where do you have only 2 atomic orbitals combined? In which hybridization?
SP.
SP, right? Obviously, 1 s orbital, 1 p orbital, 2 orbitals. So whenever you find Sn is equal to 2, that means it is sp hybridized. Okay, and whenever you see sp steric number is 3, that means sp2. Steric number 4, sp3. Steric number 5, sp3d. 6, sp3d2. 7, sp3d3, but very rare. Take that. Okay, but again, for organic chemistry, all we need is this 3, sp, sp2, and sp3, because carbon atom obviously will have only any of these 3 hybridization. Okay, so let me use this formula. I'll give you a very small example to find out. For example, if I have carbon dioxide, CO2. Okay, so please understand, we will do hybridization only for the central atom. I do not care about the bonding atoms. Bonding atoms means the side atoms. Here in this case, 2 oxygen atoms are side atom, and my carbon is my central atom. Okay, right. So I want to find what is the hybridization of this carbon. Right. Now you can use the formula. Look at this. Number of atoms attached to the central atom. So the central atom is carbon. To that, how many other atoms are attached?
2.
Correct. 2 oxygen atoms are attached. Right. This is the central atom. Number of atoms attached to the central atom. Now I have the central atom to be carbon. To that I have 2 other oxygen atoms. So obviously I have 2 plus. Now the number of lone pairs on the central atom. Do you think carbon is going to have any lone pairs?
No.
No, sir.
Obviously, right? So the steric number is 2. So definitely here carbon atom is sp hybridized. Okay, right? So I'll give you, now we'll just take an organic molecule, like to see whether this, I'm sorry, there should be number of lone pairs also. But again, 99% of times, you will not see carbon atom having a lone pair, except if you have a carbanion. We'll go for that. When I go for intermediates, that time I'll tell you how to find the hybridization. For now, just looking at it. Say if I have CH3, something like that. Okay. So now I have to find the hybridization of this carbon if I want to find, right? Now what you see is that when I find the steric number, right? Now tell me how many atoms are attached to this carbon?
4.
4, right? So I have 3 hydrogen atoms and 1 carbon atom is also attached to this carbon atom. This carbon attached to this carbon atom as well as 3 hydrogen atoms. So the number of atoms attached to the central atom is 4, making it sp3 hybridized. Correct, right? So same way if I have say CH2, again for this carbon atom also it will be sp3 hybridized, right? So whenever, that's what I told you, whenever you see the saturated carbons, saturated molecules, they will definitely have the carbon atom to be sp3 hybridized. Okay, so next thing, say if I have CH2 double bond CH2, right? So obviously in this case, this carbon atom is attached to 2 hydrogen atoms, right? And 1 carbon atom. Is it not? The carbon atom is attached to, so you can look at this, H, 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 and H. So this carbon atom has 1, 2, and 3 atoms attached, right? So obviously steric number is 3. So it is going to be sp2 hybridized. Okay, so like this, if you know the simple formula, number of atoms attached to the central atom plus the number of lone pairs in the central atom, that is equal to steric number, and based on steric number, you'll be able to find what is the hybridization. Okay, so it's not, okay, now let me ask you this question. Like generally what people do is, whenever they see a cyclo compound, they're a little confused, right? Now please don't worry, it's very simple, right? I have, say for example, this is C3H6. Right, C3H6. Now C3H6, if I write the linear chain, definitely two of the carbon atom is going to have sp2 hybridization. Correct, right? This would have been the say CH2 double bond CH, CH3. So again, you see that 2 of the carbon atoms will have sp2, 1 of the carbon atoms will have sp3. Right, but here there are no unsaturations, there are no double or triple bonds. You can see that, for example, if I take this carbon atom, right? Now this carbon atom is attached to 1 hydrogen, another hydrogen, now there is 1 carbon, there is another carbon. So again you see that the steric number is 4, so again it is going to be sp3 hybridized. Okay, so again, but if I have a ring with a double bond, yes, definitely the carbon atoms having the double bond will have sp2 hybridization. Right. So I think I made it a little clear for whomever did not remember what exactly is this. Right. So this is how you find out the hybridization. Okay, and yeah, and we'll see a little very detailed analysis when I go for chemical bonding. At that time we'll spend a good amount of time on this. Okay, for now we'll stick to our organic. What is the time? 8:11. Okay, fine. We'll do one more question and then we'll wind up. I don't want to take 1.5 hours class fully for the first day. I'll leave you early. Okay, let me. Okay, take down. Actually, okay, take this question. How many structural isomers exist? How many structural isomers exist for how many structural isomers exist for C3H6O, right? How many structural isomers exist for C3H6O in which no atom is sp2 or sp hybridized, right? For C3H6O, in which no atom is sp2 or sp hybridized. Okay, so they're giving the molecular formula and they're telling that you want to find the number of structural isomers, but there should not be any sp2 or sp hybridized carbon. Go for it. Tell me the answer. See, remember, in this case, functional isomerism can also come into the picture. But I didn't teach you, but still you know, right? Functional isomers. If not, don't worry. I'll anyways teach you. So one thing you can understand, since they don't have any sp2 or sp hybridized carbon, definitely you cannot have aldehyde or ketone. Why? Because aldehyde or ketone is having a C double bond O. This carbon atom will be sp2 hybridized. So
That is the answer 4.
4. Yeah, options are there. We will check. The options are 2, 3, 4, 5. Okay, so 4 is there. We'll check. Any other answers, or anybody is gonna object or support the answer which already was given? 4.
3, sir.
3. Okay, 3 is also there. We'll check. Okay, fine. I think everybody would have completed. I'll give you the answer. Okay, so it is C3H6O. Now, people, right? So from the molecular formula itself, I can totally understand that this molecule cannot be a straight chain compound. Does that make sense? Right? This compound C3H6O cannot be a straight chain compound. Why? Because you can see C3H6 is there. Remove the O, like O doesn't matter, it's going to come in between, right? But please understand that C3H6 definitely belongs to what category? Alkene category. Correct? CnH2n is what is there, right? So definitely I cannot have a straight chain compound. Impossible. You can try if you want. Say if I put C3H6O, CH3, CH2, now one more carbon atom, and you should put a double bond. There is no other go. Right? How will you have it? They work almost 5 over. If you put CHO, this makes sense. I don't understand. This actually gives me C3H6O. But look at this carbon. If I put an aldehyde, this carbon atom will become sp2 hybridized. Or if you put an alkene, for example, CH2 double bond CH, CH2OH, again alcohol with a double bond, but again these 2 carbon atoms are sp2 hybridized. So no, it cannot be a straight chain compound. Is what you have to understand? Okay, so definitely it is going to be a ring structure. Okay, so first thing what I can put is I can put a cyclopropane, and I can put one OH, easy, right? This is one. Next, next thing is, okay, what other things do you think will come?
So take one O, add two CH2 and then one CH2.
What is the name of that functional group?
So that I'm not sure, sir. But I just it satisfied
ether, right?
balance.
That's what ether, isn't it? That's what I've been studying. Alcohol, ether, phenols. In ether, what do you have? Ether structure, ROR structure, isn't it? COC bond will be there. Now, this is the only alcohol actually I can actually make. No other alcohol is possible, right? All the others are actually going to be ethers, right? Say what can be different structures? The different structures can be like this. This is a cyclic ether, a 4-membered ring, but with an oxygen in one of the carbons place. Okay, or I can even have a 3-membered ring with 1 methyl group. Correct? Right?
Yes, sir.
What else? Can I have anything else? I don't.
Sir, the
Yeah.
question is structural isomers, no, sir.
Hmm.
So optical isomerism will also be counted, no, sir.
No. Optical isomerism will come under stereoisomerism, not under structural isomerism. Right? Under stereoisomerism, I have 2, geometrical and optical. All the others will come under structural isomerism only.
Oh, okay.
Okay?
Sir, okay.
But if they mention just isomers, if they didn't mention structural isomers, they just mention isomers, yes, you have to include geometrical isomers, structural isomers, stereoisomers, optical isomers, everything has to be included. But they have mentioned only structural isomers. So we don't have to worry.
Yes, sir.
Okay, so I think people other than this, I don't think any other structure is possible. Do you think anything is possible? Right, that's it.
No, sir.
Yeah, so totally only 3 structures are possible. The answer is 3. So I think someone told 3. Did you get these structures?
Yes,
Someone
sir, I got these 3.
All the 3 structures? Good. Yes, nice. Right. So yeah, guys. So this is about this today's class. Like most of the time went in explaining introduction and all that. So from tomorrow's class, it will be hardcore chemistry. Right. Okay. So if you don't have any doubts, we can wind up the class. Right. I hope you've understood how we are going to go about the subject. How am I going to teach, and what level of problems we are going to solve. It's all good quality stuff, right? Okay. So if you don't have any doubts, bye. Thank you.
Thank you, sir.
Right? Yeah. Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.